Welcome to the Gold Mass Lecture. My name is Father Terry Ehrman. I'm a Holy Cross priest. I teach in the theology department, but also have a concurrent position in the biology department. And it's my distinct pleasure to introduce tonight's speaker, who is Dr. Gary Lamberti. There are lots of seats down in the front rows for anybody who's brave and adventurous and wants to come down. Right. So Dr. Lamberti is mostly known as a stream ecologist. And if one is going to get introduced into stream ecology, one is first going to be introduced to the idea of the river continuum concept that was first published in 1980 by Robin Van Noot et al. And it was really the first unified hypothesis about how streams and their watersheds work and interact. It's how the structure and function of biological communities change as the stream goes from headwaters down to the mouth. And actually, Dr. Lamberti's dissertation work was related to this in a bit because his study was on caddisflies, who are a bunch of grazers, and what they did to benthic algae in a third-order stream in Northern California. So he was very much involved in some of this kind of thing and helped showcase what the river continuum concept is about. I'll start with the most recent. And Dr. Lamberti has had a stellar career over several decades and received 2 years ago from the Society for Freshwater Science a Lifetime Award of Excellence that's given to someone for outstanding contributions to freshwater science. Also in 2022, he was named the Reverend Julius A. Nieuwland C.S.C. Professor of Aquatic Science, a chair position at the university. Now, stream work lends itself to a metaphor for life, because water is flowing unidirectionally downstream, and there's a sense of time is flowing in unidirectional. And so it can often be a metaphor for life. So I want to give my introduction to the professional and personal development of Dr. Lamberti using another stream, which is Thomas Cole. He was the founder of the Hudson School of Art, The Voyage of Life, that he painted in 1842, an auspicious year for those in this room. And it follows a person from childhood through youth to manhood to old age. And so I want to use this, and it also follows the seasons, spring, summer, winter, fall, or fall, winter. And I want to use this to showcase the developments of Dr. Lamberti professionally and personally over the years. So if we start with childhood, Dr. Lamberti comes from Oakland, and his parents, Tony and Olga, not only gave him birth, but they also gave him birth into new life at St. Teresa's Catholic Church, where he was baptized. He went upstream from there a bit to UC Davis for college near Sacramento. And he eventually became an entomologist. He didn't start off in entomology, but by taking a class with Warren Cothran, and this insect ecology class, he was so inspired by this man that he switched his majors to become an entomologist. In learning about some of his former colleagues and longstanding friends, one of them said that Gary is someone who is dedicated, loyal, and adventurous. And so I think of that as we enter into the youth aspect of his career and life. And as he began postdocs at the University of Oregon State University at Corvallis, and he's taking off, going downstream. Where will the future take him? Here's Dr. Lamberti in 1985 in Corvallis, the North American Benthological Society, which got changed to the Society for Freshwater Science. And one, he's showcasing his Italian heritage, his great love of food and drink. Now, I suspect this young Gary Lamberti didn't know that 12 years later, in 1997, he would be the president of this society, of NABS. Most of the work that Dr. Lamberti did when he was at Oregon State was in the H.J. Andrews Experimental Forest, which is part of the long-term ecological research network funded by the National Science Foundation. And so he worked on how forest practices and disturbances affect stream and processes and communities. It's whether it's in Mack Creek, where he did some studies in Lookout Creek, a fifth-order stream. Now, it's always fitting and advantageous, fortuitous perhaps, if one has a volcano explode in the United States during one's research career. So this is what happened in 1980 with Mount St. Helens, for those of us old enough to remember that, right? May 18th, 1980. And so one of his papers and research was looking at how do streams recover from these catastrophic disturbances in ecosystems. Now, Gary is known for his accolades in teaching and in research. But a lot of people don't know about his more mischievous side, as one of his longstanding friends has said to me. And so I just want to tell a brief story about Gary and sort of the more fun-loving side. I don't know, maybe he caused the disturbance of this watershed of knocking all the trees down. But so I'll just call this friend Al. And so Al tells a story that when they were at Oregon State together, it's October, and Al finds Gary looking at him, staring at him repeatedly throughout the week, and as weeks go by, and he's like, what is Gary up to? What's it all about? But he figured it out, because Gary was planning on imitating Al at the Halloween party at the end of the month. And so he was observing all of Al's mannerisms and idiosyncrasies. He even asked Al's wife for some clothes that Al would typically wear. He pasted on a fake beard, because Al had a beard. And so it was to great success, because Al's dissertation advisor actually thought that Gary was Al. But Al says, this event exemplifies several elements about Dr. Lamberti, about Gary. One, his fun-loving nature. Two, his commitment to ensure accuracy in all his undertakings. And three, the strong bond of friendship he has cultivated throughout his career. There's a human element that hopefully everyone brings to science, and Gary very much brings that human element to science. Even as he's progressing down this stream of life, there's always a youthful dimension to Dr. Lamberti, and his great love of fishing, even fishes that might be bigger than he is. The person that took this picture said, well, I don't even know if Gary could lift this fish. He needed some help to get this thing out of the water. So moving from youthful exuberance into manhood, Dr. Lamberti now has to professionalize his vocation of studying the natural world and his great love of science and the natural world. So he has to get a job. And so he comes to Notre Dame in 1989, and I become his first undergraduate to work with him. I took his class in 1990, topics in ecology, and was his first undergrad researcher in his lab. There's the two of us in St. Patrick's Park when I was a grad student at Virginia Tech. But besides undergrads, Gary has also overseen the development and professional development of lots of master's students, doctoral students, and postdocs. And this slide was provided by Dr. Jen Tank in the department to talk about the legacy, the Lamberti legacy tree. Now, he had to leave behind his great love of all things Northwestern, in the Pacific Northwestern. And so when he comes to Notre Dame, this isn't the Cascade Mountains anymore. So he says, I need to do some research that's more local. And so he says, I'll know what I'll do. I'll study the Great Lakes and some of the invasive species that occur in this area. So with his grad students, he studies round gobies and Eurasian ruffs and zebra mussels, among others. These are all the invasive species in the Great Lakes watershed. Manhood also has more responsibilities and duties, right? How to get tenure. So he accomplished that. How to become a full professor. He did that. But there's also things that one has to do as one enters into adulthood that one might not want to do, but it is one's responsibility and duty to engage the community in a different way, particularly with management. So over this time, Gary becomes the chair of the biology department from 2008 to 2014. He becomes the director of GLOBES, which is the graduate certificate program in environment and society from 2015 to 2020. He's an NSF program director for environmental biology from 2020 to 22. But in the midst of all of that, he never leaves behind his great love of research, and particularly of the Northwest. And so he began studies in Alaska, looking at what happens with salmon when they go back upstream and nutrients that are transported upstream and out of the stream. Gary's work, Dr. Lamberti's work, has always been collegial. He's always been out in the field with his students, teaching them. He's also won several teaching awards here at the university in his last several decades that he's been here. It continues into the broader communities of South Bend with the Robinson Community Learning Center, the Center for the Homeless, where he'll engage and teach the communities there. And now that he's even emeritus, he just retired in the spring of this year, but I don't suspect he's ever had a fuller schedule than he has now, even in being retired. And he continues to do research. His latest foray is into PFAS, this forever chemical. It's a toxin that's found in all ecosystems, and it's in human beings, and looking at how do we study the natural world and humans and their interactions with one another. Along this journey, this chronological years are accumulating as we move into the final stage of life, which hopefully is many years away, right? Old age. I think that old age is really it is a chronological measurement, but I think one's spirit is also a great testament about how one enters into one's life. Because there's always the youthful twinkle and smile with Gary, a ready laugh, and I think that will serve him well as he continues downstream. But the last thing I want to say about this journey that Gary has been on, that Dr. Lamberti has been on, is to go back to St. Teresa's church, because orthogonal along this stream, all along the way, has been a desire for a different kind of stream, which is from Psalm 42, like the deer that yearns for running streams, so my soul is yearning for you, my God. Right, all along the way, he's been this Catholic scientist doing all this work. And so I'm very excited and eager to hear from the wisdom that he's accumulated over this journey downstream across ecosystems, but along life itself, to talk to us today about different linkages, how humans are connected to the natural world and it to us and all of us to God, as he talks about the global freshwater crisis, science, society, and spirituality. So let's...
Thank you, Father Terry. Everyone hear me okay? Fantastic. Mind if I lose the coat? All right. Hey, thank you. Indeed, Father Terry, as he described, was my first undergraduate researcher in my lab when I arrived here. And the first paper I published as a faculty member at Notre Dame was Ehrman and Lamberti, 1992. So I would hold that Father Terry propelled me to tenure and my long stay here at Notre Dame, which has been a gift throughout. So I'm going to scale up what I've done from little caddisflies and algae to maybe some fish to some invasive things to chemicals, emerging chemicals, and talk to you a little bit about the global freshwater crisis that we're encountering. And I would hold that the two quintessential environmental issues of the 21st century are water and climate. And those two things are intertwined. And the nexus of those two things is where we're going. Everything spins off water and climate in an environmental sense. And so Notre Dame, all of us need to pay attention to those two topics as we move forward because they're so extremely important. But I'll talk about one of them in particular, and that's my favorite topic, water. You look at this image, right? It's the blue planet. What's the issue? Why is this a crisis? We have water everywhere. Well, do we? Water that we can use? And I'll start off with relating water to really spiritualism. Religion, Christianity, any other religion, is imbued with symbols of water. These are just a few of them. Baptism, the flowing grace, holy water, Jesus as a living water, and of course miracles. Many of them have water as a central part of miracles. And the list goes on, and not only in Christianity, but in many other religions as well. So water is central to religion as we think about Christianity in particular. And also related to Laudato Si, the Pope Francis's encyclical from 2015, and speak about water a bit in terms of our common home. And this is just one quote. The bold is mine, by the way. It's not in the original writing. But fresh drinking water is an issue of primary importance since it is indispensable for human life and for supporting terrestrial and aquatic ecosystems. Simple but profound thought, and kind of encapsulated what I'm going to talk about today. So I think we could plausibly argue and ask the question, is water the new oil? We have a lot of substitutes for fossil fuels now for oil. There are lots of other ways to make energy, and we're starting to develop many of them. But is there any substitute for water? Anyone? None at all, right? Our bodies, after all, are 2/3 water. So there's absolutely no substitute for, in our case, fresh water. Now, those of you who remember what newspapers are, nobody under 30 or 40 knows what a newspaper is, right? You get all your information from the web. But these are the things we open on a Sunday morning over your coffee. And sometimes inside a newspaper is something called the Parade magazine. Doesn't even exist anymore, right? It's out. But if you scroll back, some 25 years or so, and look at this cover story in the Parade magazine, this insert to your Sunday paper, an article by Senator Paul Simon, the late Senator Paul Simon from Illinois. Anyone remember Paul Simon? The senator, yes, some of the older folks. And in this article, Paul Simon was not only a senator, but also an intellectual, was a professor at a university for a while, and a conservationist. He said, as the Earth's population grows, nearly 6 billion today, it's actually 8 billion now, the demand for water is increasing even faster. Unless solutions are found, the result could be shortages, famine, and in some parts of the world, even war. So let's think about that for a little bit. By the way, this Paul Simon is not Simon and Garfunkel, okay? Even though Bridge Over Troubled Waters might be apropos here. But when will we run out of water? Will we run out of water? And for those of you who are kind of in a food coma from enjoying the food back in the Galleria, or maybe just are going to zone out sometime today, I'll give you the punchline right now, right at the beginning, which is the water that we use, the water that we see from our faucets, going through a dam for hydroelectric power. All these different uses, kind of our vision of water, depends on that ecosystem to the right for supplying that water. That's an image, by the way, from Alaska. Which one should I point to? Alaska, where I work, and all these dark things are Pacific salmon. They're all salmon, good fishing hole. But the point is that the water we use, it's imperative that we return that back to ecosystems in good enough qualities to support those ecosystems, because those ecosystems support us and support our water use. And so this circularity in terms of water use and water provision is sort of central to how we need to think about this resource. Okay, so a few fun facts. Only 2% of the planet's water is fresh, and most of that is ice, at least for now. That's where climate comes in, right? So by the way, there will be a quiz later on, so just pay attention. Okay, so what does this look like? The grid to the left in this image is the global mass of water. That's the global budget of water in every ecosystem. Well, most of it is dark blue because that's ocean, and it's saline. And yes, we do know how to desalinate water, but it's expensive and energy intensive. And so the water, the fresh water, is over here in this sector, way up here in the corner. The turquoise color here are ice caps and glaciers, okay? Can't immediately use those, they're melting, we know this. But down here is groundwater, the light blue. We know how to get to groundwater. But that little tiny, that little tiny red circle right here, that's all the surface fresh water on the planet relative to the entire budget of water, the entire mass of water, okay? That little tiny speck. There's still a lot of water, but minuscule in a relative sense to other sources. Okay, and of all the liquid fresh water, most of it is underground. Okay, we know how to get to groundwater. We sink wells. We know how to do that very well, but sometimes we don't do it so well. So here's another quote from Laudato Si. Pope Francis says, water supplies used to be relatively constant, but now in many places, demand exceeds the sustainable supply, with dramatic consequences in the short and long term. So what does this look like in real life? Well, let's take the Ogallala Reservoir that extends all the way from South Dakota down to Texas. Okay, it's a huge aquifer that is a groundwater resource, supplying the water for the breadbasket of America. Okay, so it's extremely important, and yet it's a tragedy of the commons. There are so many wells now in the Ogallala that it's depleting at a much higher rate than it's replenishing. And by all accounts, within decades, the aquifer will be basically depleted of water taking centuries for it to refill by natural infiltration from precipitation. So we're overusing that groundwater supply, and we know this is occurring. My home state of California, we'll think about that one. And if you look at the Central Valley of California, just for scale, that's Monterey Bay to the left there. In this NASA image right now, there's so much groundwater being pumped out of the Central Valley of California, which support just the vegetable basket of America, vegetables and fruits, and increasingly nuts, very water intensive. But that image shows subsidence of the land. We're pumping so much water out of the Central Valley that the land is actually subsiding and compressing. It's like a sponge, squeezing the water out of the sponge. Or I think about it as those little magic animals that you would buy as a kid that you then filled with water and they expand, But so much water extraction, groundwater extraction, that the land is subsiding up to a foot a year in some areas, generally much less than that, but perceptibly. And this image from the U.S. Geological Survey of where the land was in 1965 and where it was, about 50 years later in 2016 and continuing to subside. And it's a cycle that once you remove water from the groundwater, the hydrostatic pressure, of course, declines, and then you can fill with less water just because of the compression. The interstitial spaces have been reduced. And then, so the solution is you drill deeper for water, but you drill deep enough in some of these aquifers and you hit marine fossil water, so that's saline water. Once you hit saline water, it's game over for irrigation. You can't irrigate anything with salty water. Okay, so that's one issue. Freshwater is unevenly distributed on the planet. And again, Laudato Si, some countries have areas rich in water, while others endure drastic scarcity. Water poverty especially affects Africa, where large sectors of the population have no access to safe drinking water. So let's look at that in terms of a heat map. So this is United Nations Environmental Program, developed these maps, so they're authenticated. So the global freshwater stress here, the warmer colors means there's less water per capita. That is, less water per person per year. And as you get to the warmer colors, you have more water issues, less water availability. And so the usual suspects come up here, right? We see Northern Africa as being water stressed. Well, a lot of this is desert. The Asian subcontinent over here, even some European countries, South Africa over here. So many African countries in particular have low amounts of water per capita that they can even exploit if they were able to. Here, where we live, on the other hand, we have the Great Lakes. So the Great Lakes, we're in the watershed of the Great Lakes. South Bend is right there. And so we're in this watershed. And we have an abundance of riches in this Great Lakes. 95% of the U.S. freshwater, 90% of all North America, is in the Great Lakes, surface water. And 20% of the world's surface water is in this one resource. So we don't think about it a whole lot. When we open the tap, clean water comes out of it, and abundant water. We irrigate our lawns and do all that because of this abundant resource that we have. However, there are, of course, parts of the U.S. even where it's not abundant. Think about the arid Southwest. This is an area of water stress. And what's been thought about on numerous occasions is taking water from the Great Lakes and putting it in a giant pipeline and transporting it to Phoenix, okay? You can't do that now for a bunch of legal reasons, but this pops up. These ideas pop up, very frequently about pumping water from the Great Lakes to another place that's water poor. We think it can happen, but just imagine in the November elections if Arizona tips it one way or another. Okay? There's going to be payback, right? There's going to be gifts out potentially for that part of the U.S. Unlikely, but the specter is there. Another fact, over 50% of the world's accessible fresh water is already being used by humans. That is, 1 out of every 2 molecules of fresh water we use for one purpose or another, sometimes multiple times. Okay, so very little free-flowing water that goes, say, from a mountaintop on the river continuum all the way out to the ocean without being used by humans. Okay, so this is where the quiz starts. You thought I was kidding. So this is global water use, which of course over the last century increases with population size. There's a little bit of evidence that maybe it's starting to level off a little bit in recent decades due to water use efficiencies, engineering and science contributing to that, and people using less water. However, still a lot of water being used. So the quiz here is, what do these different colors represent? So if you look at this light blue right here, this is the big user of water. Don't say it out loud, just think it in your head, okay? This is like on the honor system. Don't blurt it out, but what do you think is that major water use? About 2/3 of the water being used for one major purpose. Everyone thought? Have it in your head? Everybody? Okay, so who thought agriculture? Yay. Irrigation? That's good too. If you thought agriculture, irrigation, any of those, that's the big dog right there. And we need to eat, right? We have to irrigate our crops to produce food. We don't have to use 2,000 gallons of water to produce 1 pound of beef. 40 gallons of water produces 1 pound of vegetables. So, keep that in mind too. Okay, so if you got agriculture, you get a point. What about this next one? The red there, maybe about 20% of the global water use is for that purpose right there. Think it in your head. Everybody got it? Got something in mind? Okay. Industry, cooling. All manufacturing needs water. So anything that we produce generally needs water. So that would be industrial use of water, okay? How many are up to 2 points already? All right, quite a few, excellent. Okay, this green one, a little smaller, maybe about 10% of total water use is this little green part of the graph here. Think about that in your head. What does that 10% represent? You ready? Urban or municipal water use, what's coming through our taps, what's going down our toilet. All those uses are urban or municipal. Anyone get that? Awesome. Some of you are 3 for 3. This final one is a little more subtle. Oops. That purplish one, I have a little color blindness, but purplish one is actually a water loss. So it's not a use so much as a loss. So I'll give you that little clue. So think about that for a second. Where are we losing water? I'll give you another clue. It's not out of the pipes. It's not out of the pipes. Okay, even better clue. Okay, this one is a little more subtle. We'll see. You ready? Evaporation. Dude, we built so many reservoirs, so many impoundments, that water is to store water, but that's a major loss to the atmosphere by evaporation. Now, eventually that enters the hydrological cycle through cloud formation and precipitation and the like, but as an immediate loss, it's coming off all the reservoirs that we've built around the planet. How many got that one? That was a little more subtle. Oh, a few people. Awesome. Okay, so you got up to 4 points now, so keep tally of this, and there'll be another quiz later. Okay. Final point here is that, can you guess where this is? Here's an image of some city employees and maybe some volunteers, and it relates to what we were just talking about, dumping millions of black balls into this water body, black plastic balls that float. And so the net outcome of that is that. And so, so think of your mind where this happened and maybe for what reason. So think in your mind where this happened. Okay? You ready? How many thought Southern California, Los Angeles, Orange County, Anything? A few of you did. Yes. And the reason is, during the California drought, which has been ongoing for decades, really, in one way, shape, or form, they put these polycarbonate plastic balls, why black, since they absorb heat? I don't know why they would do that, but on top of these reservoirs to prevent evaporation, to prevent loss. And it was pretty effective at doing that, to be honest, because, you know, there's such a terrible drought going on in California that they had to save water any way they can. These are like these little urban reservoirs that are perched everywhere in California. Every community has its little reservoir supplying their water. One of the problems here, though, is that these polycarbonate balls started to leach chemicals into the water. Yeah, like, bisphenol A, PBA, and other things. So they had to actually retrieve all of these balls out of the reservoirs. And there was a study in Nature, too, publication in Nature, that showed that more water was required to make these balls than they actually saved in the reservoir. So there was a further irony there. Okay, probably overseas. Okay, water use is another fact. Water use is highly biased to developed countries. Okay, so here's a plot of from Columbia University of per capita water use annually. Daily water use per person, not annually, daily. And so who's leading the pack, do you think? Of course, us. About 600 gallons or so per person per day for all those uses that we already talked about, from agriculture all the way through to what goes through your faucet. It's not just everything that comes out of your shower head. It's actually all possible uses. Interestingly, the next big water user is Australia, and much of Australia is arid, which is interesting to think about the big water issues in Australia. Next few plots, next few bars are mostly European countries, so developed countries that have high amounts of industry. Over here is Asia and South America for the most part. And then, of course, trailing the pack is Africa. Haiti is in there as well. But the amount of water per person available, much less being used, is much lower. And so, hence, we have a much lower per capita water use in Africa and some other developing countries. Okay. Talk a little bit about human terms. So, assuming we have about 8 billion people on the planet now, these are really coarse numbers and they get thrown around a lot, but even if they're, 25 to 50% uncertainty on either side of these numbers, they're in the ballpark. So of the world's 8 billion people, more than 1 billion people we know lack access to clean water. That is water at our standards. Water that comes out of the tap that we assume won't sicken us and certainly won't kill us, but that's not the case around the planet. Oops. And, okay, yeah. So there's the quote. Again, Pope Francis, a particularly serious problem is the quality of water available to the poor. And sure enough, if we see another heat map of access to safe drinking water, we immediately see Africa as emerging as a place where people can't be assured that the water supplied to them or the water they obtain will not sicken them. The Asian subcontinent has problems. Indonesia has problems. Venezuela has a problem. So these are areas where safe water is not to be assumed to be available. And as a result, illness results from these problems. Now, I mean, if you're in North America, you're in pretty good shape, other places, but many parts of the world, no. I took this image a few months ago with their permission in Soweto in South Africa, in Johannesburg, within Johannesburg. Soweto, as you recall, is the birthplace of Nelson Mandela and Desmond Tutu. And in Soweto, community wells like this are common, and hundreds of families will be using the same taps, both for drinking water, for washing, for other sources of their water, for bringing back to the home, et cetera. And so a lot of work goes into obtaining water in some countries that will not harm you. About 4 billion people, half of the people on the planet, lack adequate water sanitation. That is, treatment of water before it goes back into the environment, back into ecosystems. And in developing countries, 90% of the wastewater is discharged without even basic treatment. Basic treatment is just settling the chunks, okay? The Clean Water Act of 1972 means that we cannot put water, municipal water, industrial water, back into a river, a lake, or the ocean without treating it, without running it through a treatment plant. And we take that for granted, that we remove the toxins, the nutrients, the microbes, the disease agents from that water before it goes back into surface water. But that's not the norm around the world. And if we look at a heat map of adequate sanitation at our level, that we expect, water to go back into the environment in reasonable condition, that's not the case planetarily. In fact, most of the world does not have water treatment at our standard. Again, what stands out is Africa, South America, most of Asia, even Russia. And North America, Europe, Australia, okay, but standards of water treatment are low most of the world around. This results in disease. So about 250 million cases of water-related diseases each year, with 5 to 10 million deaths per year due to a waterborne disease or water-related disease. That includes 4,000 children per day, and I hate to even show the statistic because it's so depressing, that about every 20 seconds, a child dies on this planet due to a water-related preventable disease. Okay, this is criminal, that people are dying from water, mostly diarrheal diseases, just dehydration from being sickened. And of course, Pope Francis addresses this as well. Every day, unsafe water results in many deaths and the spread of water-related diseases, including those caused by microorganisms and chemical substances. Profound. So there are many sources of these water-related diseases, from vector-borne diseases, from mosquitoes that breed in water that then vector diseases like malaria, dengue, and other sorts of diseases. Groundwater issues. Not all groundwater is in good condition. Some of it is laced with chemicals. But there are solutions, and Notre Dame is actually doing a lot to address water issues globally. Across the entire university, in every college, in every department almost, there are people that are thinking about and working on water-related issues. Just to mention a few, the Eck Institute addressing mosquito-borne diseases and other vector-borne diseases. H2O&D run through the Environmental Change Initiative, addressing water-related issues, especially related to water abundance, emerging chemicals in water and other issues. The Pulte Institute with the Clean Water Wells Initiative as well. That's been successful. Engineering has a bunch of initiatives related to water use and water improvement. Every sector of the university, Keough School, Mendoza, the law school, all have people interested in this issue. So Notre Dame by itself is doing a lot. Of course, we can always do more, but Notre Dame is addressing this problem in a very real fashion, which is what we should be doing. Okay, another little human-related issue. People tend not to live where the water is. I mean, think about the arid Southwest. Yes, great place to live, a lot of sunshine, dry, et cetera, but not where the water is. So water-stressed river basins will hold nearly half of the world's population in 20 years. Sometimes this leads to conflict. And this interesting quote from the World Bank Vice President Ismail Sergeldin some 30 years ago, even before Parade magazine and Paul Simon, said, if the wars of the 20th century were fought over oil, the wars of the 21st century will be fought over water. So was that prophetic or not? Well, Again, that Parade magazine article with Senator Paul Simon. Simon tried to predict where these conflicts could happen. And so these are the areas that he thought it would happen: the Middle East, the Asian subcontinent, sort of these areas of water stress. Well, I think we now know that we can add other areas to this as well. Sub-Saharan Africa, for example, we know what's going on in Sudan. Some of those conflicts are ethnically based, religiously based, but they're related to water as well, or environmental stress. So water exacerbates these situations globally. The former Russian republics, I'll talk a little bit more about those in a minute, areas of conflict over water. Southeast Asia is kind of blowing up as well, especially the Mekong River Delta, and because it's a multinational river that everyone's trying to get their part of. So there are areas of conflict. And this, I don't even bother to read all the fine print here, but this is sort of a global map of hotspots of global water conflict. And it's everywhere, right? When we start to look at it. But it highlights 4 places in this particular plot. But the only word I want you to sort of focus on is dam. There's a dam. There's an impoundment. And so it's a water grab. So one country says, I want to grab that water coming down that river before it goes into my neighboring country. And so much of the conflict revolves around water acquisition and one country intercepting the water of another country, leading to international conflict. The poster child of this is probably the Aral Sea. How many have heard of the Aral Sea? Okay, a lot of people. Well, this is kind of the poster child because when the Soviet Union broke up and the Russian republics became independent, or I guess semi-independent, there was a water grab of the rivers flowing into the Aral Sea. The Aral Sea was slightly saline anyway. It was kind of brackish, but once the rivers got intercepted and the water went to every country who could actually put a dam in or intercept it or just draw water off, the Aral Sea shrank. And its endemic plants and animals, left with it. And so the water now in the Aral Sea used to look like this. Now there's that much left. And so this has caused economic collapse. There was a significant fishery in there. A lot of the commerce and industry revolved around the Aral Sea, and now it's just a shadow of its previous self. You don't have to leave the U.S. to find water conflict, though. If you remember, well, nobody remembers this except maybe me, but a century ago, there were the Los Angeles water wars. And there's the conflict over the water as Southern California, Los Angeles basin was developing with people. Everyone looked around and said, oh, we don't have enough water to sustain this kind of growth. Where are we going to get it? Well, they went to the mountains. They went to any place to try to grab water, and people died. And if you watch this movie, anyone seen Chinatown? A few people. Okay, dial it up on Netflix. It is a great movie, and it revolves around the Los Angeles water wars, where the politics, the economics, the human conflict was all related to water, getting water for this growing population. Famously, Jack Nicholson is in this movie. Faye Dunaway, the late John Huston, famously had his nose sliced open. Anyway, so it's a very good film that has interesting subplots, but it revolved around the Los Angeles water wars, obtaining water for a growing Los Angeles, and the means people went through to do that. Okay, I'm gonna get into some familiar territory in the last few minutes here, and that's my area of ecology and environmental science. So I'll give you a few, this is kind of my wheelhouse, but I'll give you a few fun facts to start off with. First of all, we have to recognize that freshwater ecosystems tend to accumulate and concentrate pollutants, okay? Because gravity works, and water flows downhill, and lakes are somewhat confined, and rivers transport their contaminants from upstream to downstream, thereby polluting the entire river system and whatever it flows into. Freshwater ecosystems, though, harbor the world's greatest concentration of species, that is the biodiversity. There are as many species of fish in fresh water, remember that little red thing that little red corner of the plot, there are many species of fish in fresh water as there are in the oceans. It's staggering to think about this little part, of the water, total water source, has got all those species as many as the oceans because there's so many different habitats that are available to them. Half of the world's wetlands have been lost in the last 100 years. That number is about 90% for Indiana, by the way, just because we've drained most of our wetlands that we had originally. And in the US, freshwater species, freshwater organisms, represent about 50% of the federally enlisted endangered organisms. So many of you know about the Endangered Species Act. And so we categorize now those species that are threatened or endangered, and they get listed. Let's just look at this from the Nature Conservancy. This is like the vulnerability to extinction of different groups of organisms, both plants and animals. And you see who's leading the pack here. Freshwater mussels, going back here. Freshwater mussels, about 70% of them are in some kind of trouble because they can't move and move away from pollution. Crayfish, amphibians, fishes, here are dragonflies over here, some insects. But almost all these other groups are somehow dependent on water as well. They need water as well, so they tend to aggregate around water sources. Okay, everyone have a snapshot of that in their heads? All right, we get to the second part of the quiz now. How well do you know your Indiana endangered aquatic animals? And I actually, courtesy of the College of Science, I actually have prizes for those, and those are those stickers. And so if you do well on this part of the quiz, along with the other 5 points you have, you could earn a sticker. One of these for your laptop. They're very nice. Okay? All right, you ready? So I'm going to show you an image of an Indiana aquatic animal that has some sort of status. It's either state or federally endangered. Okay? State is a little lower designation than federal, but it's still of concern in the state of Indiana. Ready? Okay, don't blurt it out. Just think in your head what this organism is. There's the first one. Don't say it. And you have to do better than fish. Okay? No, not yet. Not yet. It's in your head. Okay. Everyone got this kind of thing? This is a fish that has basically stayed unchanged for 5 to 10 million years. Almost prehistoric. I mean, they're basically phenotypically, genetically unchanged, except, what we're doing to them. Okay, and they can get to be very large as well. And they have little barbels under their chins. How many people said sturgeon? Awesome, pretty good number of you. Even better, how many people said lake sturgeon? All right, yeah, very nice, sister, great. This is a lake sturgeon that used to run up the St. Joseph's River. We would have them these get to be 7 feet in length, 200 pounds, and can live over 100 years. But the sturgeons globally are in big trouble because they're big, people like to harvest them, they're long-range migrators, and so they need free-flowing rivers without impoundments to get up to their spawning grounds. They just travel up and down rivers, and so now they're blocked, and it's a problem. So, yeah, so sturgeon are in trouble. So give yourself a point if you got sturgeon, or even lake sturgeon. Here's another one. Okay, think in your mind what that is. Think about the plot I showed you before. Okay, think about that one. Everyone got it in their head? Okay. I'll give you a clue. It's not a lobster. So don't think lobster. Really, only a couple of species of freshwater lobster, and that's not this. Okay. All right, how many people got crayfish? Yes. Or if you said crawdad or anyway, crawfish, crayfish, any of those. This is the Indiana crayfish, and it's in trouble because of pollution of our rivers and also invasive crayfish that have been introduced that have come and competed with these, and as a result, and invasive fishes too that eat them. So they're basically a a species of crayfish that's stayed endangered, as was the lake sturgeon. Okay, next image. So up to 2 points on this part of the quiz. Okay, think in your mind what this is. Think about that plot before. Okay, everybody have it in their head? Okay, who said mussel? Ah, very good, or clam. If you said clam, totally good with that. That's fine, totally good. Clams have all sorts. This is a freshwater clam, freshwater mussel. You know, there are lots of marine clams, but these are the freshwater version. These are in big trouble. They can't really move very much, and so they can't swim away from pollution. They have all sorts of interesting names. People that name mussels give them great, colorful names. This is called the rough pigtoe mussel. Pigtoe, because it looks a little bit like a pigtoe, right? A little bit on top, you know, when you really think about it, if you look at the toes of a pig. So this one is federally listed. So this is federally endangered, so even a higher status. So very few of these left in the wild. Okay, next to last image, think about what this is. Okay? Everybody got it? Okay, you have to do better than insect or invertebrate. Okay, it's a dragonfly, right? How many got dragonfly? Awesome, there you go. Anyone tell me exactly what this one is? I bet you Jen Tan can. Heinz emerald, dragonfly, those big green eyes on it. Big green eyes. So this Heinz emerald is, we're not even sure there are any left in Indiana. We know they're in southern Michigan, a few populations, but they live in the burrows of crayfish, like that Indiana crayfish. Once those Indiana crayfish decline, so does the dragonfly. So it's all connected. Okay, last image. This is an interesting one. Okay. Yes, and you have to do better than snake. Okay. So think about what this might be. If anybody gets this, I'll be really impressed. This is a wetland. You know, you think it's not aquatic, it's a snake. Well, it's an obligate of wetlands. And so it is, but look at its color, look at both ends of it, etc. So, all right, you got it in your head? How many people said rattlesnake? Yeah, very good, because if you look closely, there's a little button rattle at the end here. Kind of has that color anyway. This is called the Eastern Massaga, Indian name, Eastern Massaga rattlesnake. It's the only rattlesnake that we will find in northern Indiana. It's very timid, though. It's not scary. It will run, you know, crawl away if you get close to it. It's found in wetlands, though. The only place you find it in wetlands, we've lost most of our wetlands, and as a result, this organism has declined in abundance, too. Okay? So it's, again, habitat. It's connected to habitat as well. So if you said rattlesnake, perfectly fine. Okay, so how many people got 5 out of 5 on that section? Good job. Yes. Yes, I got a few of you. Okay, so total up all your points now from the 5 initially to the 5 now. And how many people got 10? Father Terry? You teach aquatic ecology. How many people got 9? Awesome, you get a sticker. How many people got 8? Okay, 8s get a sticker too. But then I'm going to run out of stickers. So for 9s and 8s, and how many people got 7? Okay, 6. How many people got more than 0? Awesome. Okay, good. Okay, a hand to all of you. All right. What did I say? 9s and 8s get to come down? Did I say 7? 9s and 8s. Or if you really, really just want a sticker, come on down anyway, until I run out. Okay, but come down afterwards, get your sticker. All right. So let's wrap this up now in about the next 2 minutes. Yeah, I've told you like gloom and doom, but the flip side of that is what can we do about these issues? Notre Dame is doing a lot right now. You can always do more. Water, climate, the issues of the 21st century, it's clear. And we need to contribute research and education to those efforts and outreach as well. society, right, is responsible for the consequences. We cause these issues, but we can provide solutions as well. Where does science and engineering come in? They link those things. Science tends to detect issues, engineers solve problems, right? And so we can help these to solve, to bridge this gap from cause all the way to solution. But I'm really of the mind that none of this happens without public will. So without society buy-in to the issues at a global level, without public will, without your votes, without everything that goes into solving these water issues of the planet, all spins around people and you, each one of you, and the people that you can talk to. Because we can do tangible things to help solve these issues. Conserve and reuse water. I mean, this is like fundamental. We just have to use less water per capita. 600 gallons a day per US person is too much. There are ways, and technology helps this. New and novel technology helps to increase water efficiency use and reuse. And so science, technology, public engagement into these issues will help us to reduce our water use, eating low on the food chain. We have to create a blue economy. So we think about a green economy, one that's based on the green revolution, producing more and better foods in a more environmentally safe manner. But a blue economy is just as important. So an economy that revolves around water. Here around the Great Lakes, we're perfectly poised to enter the blue economy. So we need not only a green revolution that's been happening for the last few decades, but also a blue revolution in how we think and use water, because there'll be economic benefit from using water well and conserving this precious resource. We have to cooperate. I mean, nothing happens unless we cooperate at a global level. Countries can't fight over water. Countries have to allocate water in an appropriate manner. We have to use water in an appropriate manner. We have to care about our neighbor. And so using water and cooperating among people, so you can act locally, you can think globally, but also act locally to help solve this problem. So cooperation is going to be needed. Finally, sort of related back to a spiritual concept, is we have to care for our common home. And it is our common home. Like everybody who lives on the planet is in commonality. And so that's what Pope Francis emphasized. And so thinking about those issues as a common good is where we really need to be focused on. But I'm going to leave you with another quote, which it's also a spiritual quote, but it emanates from the Havasupai Nation, the people of the blue-green water, the original occupants of the Grand Canyon. And in the Havasupai Nation belief is this about water. Whenever you come across water in its natural state, you approach it with respect. You introduce yourself to it. Take time to pay respect to it. For water gives life. We live inside water for 9 months in our mother's womb. Then we follow that water into the world. It is sacred. We depend on water for the rest of our life. Water is life. Thank you so much.
Thank you, Dr. Lamberti. You'll field some questions?
Of course.
So I'll pass, if you've raised your hand for a question, I'll pass the mic to you. If you can just say who you are and your kind of state in life, undergrad, grad, faculty. We'll have some time for questions.
It's also 8 p.m., so if you have to leave, go for it. It's okay. It's okay. There's one right here.
Hi, my name's David Richter. I'm a professor in the Seas department.
Hi, Dave.
I just wanted to ask your opinion on, you talk about conserving water, but what do you say to someone who's like, well, what's the point if the vast majority of it is being used for agriculture? I mean, what does it mean if I just use slightly less in my house?
I think that has an impact as well, because it sets a precedent for you, for your kids' kids, and et cetera, about water use. It also establishes kind of a symbolic, efficiency in water use. You're right. I mean, the big users of water have to revolutionize as well how they use and think about water. But in your own household, eating a vegetable, is saving as much water in agriculture than eating, a Big Mac. And so if you think about what you're eating as well in your household, that also will result in an ultimate water savings. If you think about the water use that's used for power production, for example, turning the thermostat down, every little action you take in your household results in a cascading effect somewhere in this water budget. And so, using less water in your household actually emanates and ramifies much greater through the system. Does that make sense? Thanks, it's a great question. Yeah, Tom. Tom Nowak from chemistry.
This is biochemistry, but
Yeah.
we're related. How often does... Sorry. How often does this information get to our local politicians or global politicians who can actually make some of this go on via making correct rules?
Yeah, maybe not often enough, and often enough, right? So it's one of those situations where this information has to be transmitted in one way or another. There are probably people that are much better at this than me. I mean, Jeremy Rifkin, for example, Jen Tank sent a notice about a book called The Aqua Planet, right? So there's a brand new book by Jeremy Rifkin, a famous sort of environmental writer, on the aqua planet. So rethinking the way we think about the planet from a land-based planet to a water-based planet. Those sorts of, that sort of communication has to sort of get out. And ultimately, you're right, politicians need to be engaged and informed about this. So each one of us can write letters, right? Start there. Start with contacting your representative, your senator, your governor, whatever it might be. I mean, Indiana especially needs to rethink the way we think about, for example, wetlands and the like. And it's a tragedy, what's going on in our state alone. But thinking about that and contacting your representatives and communicating the problems and issues with water and the value of it is really important. Great question. Thanks, Tom. Jen.
Thank you, Professor Lamberti, for an inspiring and sobering talk. Amazing. I wanted to ask, though, and this often comes, I get the same questions, especially with the broader public. How do you answer someone who says that ultimately technology will save us? And that's why, this problem is solvable, but solvable through technology. Yeah,
technology is certainly part of the solution, as you know, but not the entire solution, right? Technology can take us to some degree for water savings. I mean, agriculture is a great example. Agriculture is using much less water than it did historically, but we have more mouths to feed, and so we have to produce more food stuff. And so, you can only refine irrigation systems to a certain point. But there are technological fixes, but it has to be us engaging in this problem on a daily basis. But great question. Hi.
Thank you for your presentation. You mentioned Ogallala and Aquifer, and that is something that stirs me every time when I drive west and look at those millions and millions of acres of corn and the irrigation that's going on, the amount of water, and we know that the reservoir is decreasing in volume. And every single time I ask myself, do we really need that much corn? We feed the animals corn, we also produce ethanol, and sometimes I question myself, how many gallons of water to produce a gallon of ethanol. I know the economy is very much centered on that, and we see those distilleries, and we know that people are thriving economically, financially because of that. But wouldn't it be better if we leave half of that land to be prairie grasses, to be natural, not only because of the water concerns, but because the number of birds and animals and the little species, the insects and everything that thrive, pollinators and everything thrive in the prairie grasses rather than in the corn. Nothing thrives in cornfields.
Yeah.
Is there any way to...
Yeah, you said it beautifully already. And it's interesting, in the breadbasket in the prairie states, corn growing is only a fairly recent phenomenon. And the reason so much acreage has been turned to corn in that area is because of profit and to feed beef cattle. Historically, the main crop has been wheat, barley, and other grains, which are much less water consumptive than are corn, for example, in particular, and soybeans. And so, as a result, you have a situation where, for profit, when water was available, less so now, those crops were planted there mostly for profit and for beef grain. And so there's been a complete switch in the growing schedule and what's grown in that part of the country, from wheat to other crops that need more water. Typically, I mean, historically, wheat and other crops weren't even irrigated. And so they grew without irrigation, and now they need water. And so the proposals that are on board now are to take water from surface water now because of the Ogallala, for example, the Missouri River, and pump water from the Missouri River, which has its own set of issues related to water use and endangered species, including sturgeon, from there, and use that to irrigate. So it's a mess. It's a nest of problems, and which all emanates from irrigation and water use and transitioning crops to corn and other more water consumptive. Yeah.
So what's the solution?
Get the corn out. Really, it's revert to the original grains and maybe even traditional crops that were grown there.
And some wild.
Yeah. And
Prairie grasses are
absolutely.
beautiful.
Some wild areas, yeah. But if you're going to grow things, don't grow corn.
Hey, I'm not an environmental science major. I'm like an economics major. What advice would you have for like the finance field? Like, what should they be doing to kind of help with this?
Yeah, I mean, ethical leadership. So I recorded a little a little blurb on the Great Lakes for the Deloitte Center for Ethical Leadership that they're going to show in another week or so at a meeting when I'm out of town, about ethical leadership. And they wanted to know, actually, these sort of early career business leaders about the Great Lakes and what it means to them, and as they sort of become business leaders. And so, and the pitch I made is the Great Lakes the Great Lakes watershed supports a $6 trillion economy when you combine Canada and the US. $6 trillion. Half of that goes to wages, okay, of the people that live around the Great Lakes. And it's all dependent on the Great Lakes. Every large city is built on a coastline. If you look anywhere on the planet, you know, if you're not a country that's landlocked, it's on the coast. And so the Great Lakes drive that economy in very real ways. And so, but protecting and doing the right thing for the lakes means that your business will be successful as well. So the blue economy, all revolving around the lakes. If the lakes are dead, you know, then the economy is gonna tank as well.
Thank you.
Great question, though. Love it. Take one more, and then we really ought to let people go. It's getting late.
Thank you, Dr. Lamberti, for your talk today.
You bet.
My name's Elliot. I'm an undergraduate here at the university.
Hi, Elliot.
I'm curious what your thoughts are on how to cut down on the agriculture impact, if that's the largest category. You say that like technology can be some impact, but of course there also has to be a human cooperative component. To me, I'm interested by the idea of like regional agriculture and how we could cut down on like transportation and that sort of thing. I'm just curious what your thoughts are on like what are the innovations and strides we need to make to try to reduce that agricultural like water efficiency and like the impact of that.
I mean, there's a lot in that question, Elliot. I'm not going to do it justice, but I think all the things you mentioned too, I mean, technology that results in lower water use, planting crops that need less water as well is part of the solution. Eating locally, so going to your farmer's market. I mean, a lot of water and other energy use for that matter revolves around transportation. So transportation is huge for getting food to market, for example. So all of those things in combination have to be thought about in terms of agriculture. I think we start, by trying to eat a little lower on the food chain to begin with because of the water consumption by vegetables relative to meat products. So that's part of the solution. Traditional crops, planting crops in the appropriate place. I mean, for the water regime and the precipitation. Historically, in the Midwest, there was very little irrigation at all. All crops almost, but with climate change and the like and changing weather patterns, that's all changed. So all of those things in combination, Elliot, but it starts with you.
Thank you.
Thank you.
Well, let's thank Dr. Lamberti again for a wonderful talk. And